So I'm going to walk through the flowchart that I did here, and I'm gonna try to explain or talk about the parts that I thought that are a little bit confusing. So it's basically the KIO library, which is it's basically this code here that is used inside of this other repository here, which is Dolphin, which is a file manager for Linux, I think. So I was trying to understand the flow of the not data, but like what happens when you open a directory for the first time, and trying to find out where the optimizations are implemented. So that's why I did this flow chart here. So I'm just gonna follow through and then explain because there are some parts on the end there that are a little bit confusing. So basically it starts here. So this is the, and I might be wrong about some of this stuff, but yeah, I'm just gonna explain what I'm thinking right now. So it might be wrong. So, but I'm pretty sure that it is correct. So the way that it works is it starts off here on the open URL function. That's the function that is gonna be called on the Dolphin library, on the Dolphin framework. That is gonna be on the model parts of the Dolphin framework. So you have the model, which is done by KIO, and then you have the front end, which is done by Qt. But KIO also uses Qt a lot for a lot of their stuff. Then this one is going to use a cache, which is a Qt thread local storage, which is basically this function here, and this stuff here, which comes from Qt, which I still don't understand very well how it works. But then from that point, it's going to call this list directory, and then it's going to initialize the job. This stuff here doesn't matter that much for what I was trying to figure out, but I think it's something related to the front end. But then this function here is gonna initialize the list job private and this list job. And then I wrote down the list job hierarchy of constructors to understand what happens on the constructor of each one. And also, so basically this is the relationship here that I wrote down last time of the classes. So I have the initial one there, which is the one that calls open URL. Then I have this one that, as far as I understand, is the cache for this one. Then you have this list job private, which I think it is, yeah, initializes list job. List job is initialized with dependency injection by passing this list job private. So, but list job I think is the main one that is going to be the class that is responsible for like organizing what happens. Then this class has this scheduler class, which is the class that manages the work that is going to be done. And this one has this protocol, but so it keeps track of the protocol through the map here, but it is not a member variable. So just uses this initializes the protocol from a function and then puts the protocol on the map. So that's how it connects the protocol to the scheduler. And the protocol, this is one of the parts that is confusing that I'm going to go over the flowchart there, but the protocol has the simple job as well. So this is basically the connection between the classes. So usually for like, as far as I understand, for each task you're gonna do, each task that Dolphin is gonna do using KIO, is a job is gonna be initialized, which is a class, and then the job is gonna use the scheduler, which is kind of like the manager between queues, and then each queue is gonna have a bunch of jobs, I think. But I think for the flow that I watched there is just this job. So it's just the simple job class that is used inside of the protocol. And then the protocol is going to be the thing that initializes the worker. And then the worker is kind of like a separate thing. Because you can have multiple different protocols for, because the way that they do it, and this is from ChatGPT, but I assume I think it's most likely correct. They use inter-process communication, which is basically the KIO, which is the main process, is going to open another process, and this other process is going to be the actual worker. And then depending which kind of protocol you have, because the way that it works is more similar to the way that actual communication between client and server on the browser works. So you have different protocols, and depending on which protocol you have, you're gonna have different standards of headers and stuff like that to initialize the communication between the one process and the other. And then the worker is gonna be the thing that actually does the work, obviously. So it reads the data from the directory and then sends to the main process, which is the thing that initializes. So this is one of the parts that is kind of confusing. But the final function that runs is start a job, which is from the product queue, which is the actual function that is going to initialize the worker and starts executing everything. And then scheduler is a singleton class, so it calls the function like this inside of the this job constructor because it is a singleton. So yeah. So basically, this is I'm gonna follow the constructors here. This is the simple job init function, I think, and the scheduler is called like this on the simple job init, which I think, hey, thanks for the follow, which I think happens on the, yeah, it happens on the constructor, the first constructor, which is simple job constructor. Then from this scheduler do job is gonna accept this queue here is another part that is confusing. But according to GPT, and I think GPT is correct about this, the queue is just a way that because KIO uses Qt, and these classes are inheriting from Qt object, I think, which is the base class of Qt, they have something, they created something that allows you to access the instance of the class through a pointer, which is called pointer implementation on C++. It's a pattern. And the way that you can access is through this queue here. I didn't pay too much attention to the nuance, but a lot of the times there is this relationship between. So you usually have like a public class, which would be like simple job, and then you have simple job private, which is the actual implementation of a class. So it exposes everything to a public class, and what creates the bridge between the two is the pointer. So as far as I understand, this queue that is being passed here is the simple job class here. Yeah, queue here is the pointer to the simple job class, blah, blah, blah. So this one is gonna call do job from the scheduler private. Then it gets the protocol, initialize the protocol on the job. And I think this is one of the parts that is kind of confusing. But yeah, so here is gonna be the proto queue. This is the first function that calls here. Then later is gonna be the proto queue job. But I'm gonna go over this one first. So it calls this function first. This one, I think it's, so it tries to get the queue from the hash that connects the scheduler to the queue, like I showed there before. Basically this hash here, there's a connection. And then if it doesn't have, then it's going to initialize for the first time, and then it's going to put the queue on the cache. So it's basically, yeah. So first time that it runs, it runs the code inside here and puts the queue on the cache. But then the queue constructor is going to run here. And this signal here, it comes from Qt, the connect. And this is not going to run right away. It's going to run after the queue job. So that's one of the parts that is confusing, because inside of this start a job function, it checks, it loops over a hash, I think, that exists inside of the queue. And it already has the job, I think. I think it's the job inside of the hash, because it runs queue job first. So this doesn't run right away. It's going to run after the queue timer timeouts is, the signal is emitted, and this signal is going to be emitted through the mstart job timer, I think, on one of the functions that it has. So basically it doesn't execute this right away, but this is going to be executed later after the mstart job timer calls a function on the end of the queue job, I think. So it queues the job first, then after the timeout signal is emitted, it will run the start job. So this is basically the queue job. This, I think that's, yeah, here's another part that is kind of confusing. But this thing here is a dictionary, is a hash map. I think it's a hash map that is going to keep track of the queues. So it has, I think for each scheduler, it is possible to have multiple different queues, which depends on the URL protocol, I think. So it's basically this host name here, the way that they keep track. And this doesn't exist in the beginning. So when you try to access this through the square brackets, if it doesn't exist, it's not gonna create a dangling reference. It's gonna implicitly insert the value on the hash map. But this part I'm not 100% sure, but I think that's the only thing that makes sense because I search for the thing here and didn't find anything. So I think the first time that it's running is gonna put the host name and it's gonna map to it's gonna create a new host queue, and then it's gonna map to this host name here. So it's basically mapping a string, queue string, to a host queue. A host queue is gonna be the thing that is that has the jobs. And so basically at the end, so this is the part here. When you call this function from the timer there, from the signal they're connected, this is the function that's going to meet the signal there that makes the other class. I think it's from the queue that calls start a job. It's basically going to call start a job after it calls this function here at the end of this. But at this point, it already inserted. So it inserts the queue on the map. Yeah, I think that this is the map here that's going to loop over on start a job. So it inserts the queue on the map based on this lowest 0, which I didn't went over, but doesn't matter that much for what I was trying to do. And also enqueues the job. And this job here, the one that is being passed, is the one is that queue value that it passed before, which is the original simple job that created. So like this queue here is going to be this simple job here, which is the original job from the beginning, is the constructor that is running basically. So that job, as far as I understand, is going to be the same one that puts on the queue here. So this job here is the class there on the beginning. So it puts this job on the queue, and then it puts the queue on the map, on this map here. From this proto queue class, which initializes on the scheduler. Then this is the start job, I think, function. So this one is the one that is gonna loop over. So this map here is the same one there where it puts on the previous function. So this one is gonna have the host queue, which is the one that initializes there, implicitly initializes when it puts on the hash. And then it's gonna get the job, the same job there from the beginning, using this take first in queue. So this starting job here is the same one that ran on the constructor in the beginning. And then it's gonna call a bunch of functions to initialize and set up the workers. And I'm gonna go over. So this is where it starts getting very confusing. But this is basically the main one, I think, that initializes the actual worker. Yeah. So the first one that runs here, so there's a lot of stuff I'm gonna have to remember what parts are actually the most confusing. So I think that the first one that runs is this one, which I didn't spend too much attention. It's from this worker managed class, but it basically, as far as I understand, is gonna look for. So I think it's just the same principle from the other stuff. The first time that it runs, it's gonna initialize things, and it's going to check that it doesn't have, and then later it's going to put it on the cache. So this function basically checks to see whether or not there is already a worker on the cache, as far as I understand. And I think it maps based on the job. So the job in the beginning there. So in the first time, it's not going to have on the cache, so it's going to call create worker, basically. I'm going to read the stuff that I wrote down here. So this checks to see if there is already a worker on the task. They map the URL path to the worker. If there is already a worker for that URL, it returns that worker. If there isn't, it returns a null pointer. Yeah. So then it's gonna call. I'm thinking about the first time that it's gonna run. So it's gonna call the create worker, which is basically this proto create worker function, because it calls this from inside of the proto. Then this was one. I think the part that is confusing is later, actually. So queue worker is found on source queue worker on the queue source code. It's built as a separate executable. Yeah, so this is one of the parts that is confusing. So inside of this function, I'm gonna go over again from the code. But inside of this function at the end there is gonna run, it's gonna use another library, an external library that I think it doesn't have. Like I don't have the code here for the library. It's basically at the end here of this. So this is the function that is confusing. So this function is gonna basically create the worker. It's based on the protocol. The protocol is the stuff that I was talking about. That it depends on which kind of. So I think you have a file, HTTP, and web, and like different kinds of protocols, because it opens like a bridge between the two processes, and it works in the same way that normal browser to server connection would work. So based on this protocol, here is gonna get this name, and then it's gonna run the constructor of the worker. I don't remember. I think there isn't a lot of interesting things on the constructor, but at the end here is going to use this library here, which I couldn't find. I think it's an external library, but it doesn't have on this code here. And then it uses this search path to get a string of queue worker executable. And then it uses this queue worker executable string on this queue process, which I also didn't spend time going through the source code of Qt to see what queue process does. But obviously, I think it's pretty intuitive. So basically, it probably creates another process, and the way that it creates is based on the string. So when I think what is happening here is that it's getting the string for the executable of the queue worker, which is saved on the same directory of the project, the final project, after we build everything. And then it's gonna open another process using this set program from queue process. And this string here is the part that is confusing, and it basically, and then it's gonna like connect this other process here through the worker class that it initialized before, through this PID, which is the process ID. So it basically creates the bridge between the worker class that initialized on this process and the worker executable, which initializes another process. But basically this, as far as I understand now, this program here is gonna be on the queue worker folder. So it's basically this folder here. And the way that I figured this out just by looking at the CMake. So on CMake, when you have add executable and you put the name, this is going to be the final name of the executable. So I imagine what is happening is that when you compile this project, it's going to create a queue worker executable in the same folder. And then it's going to find this executable through this code here. So that's basically what this code is doing, is finding basically this the executable for this file here. But this part is also a little bit weird, because here, so basically, you can think about it, the first time when it loads there, the process is going to run the main function for this process. And then the arguments that it receives here come from the other code. So I think I wrote down there, I don't remember really well, but it's basically these arguments here. And then it's going to use that to run another function. And this is the part that is confusing. So like it passes these arguments here is receiving from the other, from the create worker function. And then basically what this code does here is load a library that is based on the protocol you're running. So I'm not going to spend too much time on the details, but it's basically, it's going to run this KDE main function from the library. And the reason why it does this, so it does this at the end here, this function is going to depend on which protocol you're running, because that's how create worker works. And the reason why it does this is because it has several different protocols. So imagine that for, depending which kind of task you're doing, you're going to use different workers, and because each worker is going to have its own protocol. But it's basically going to run, you can think about the executable as running these files depending on the protocol here. So this one, the file would be for normal file system, I think, as an example. So I think that the main function is going to be KDE main, the name of the function. And I think it's always defined the file that has the same name as the folder. So basically this is going to be the entry point for the worker. So you can think about this as being a different process that is going to communicate with the other one through the protocol. And this file here, these folders, each one is going to be related to a different worker. These are actually the things that have it's both this and another class that I'm going to show there. But this one is going to be the class that actually does the work. So this one has the functions for the low-level API that are going to communicate with the operational system. Yeah, so basically equates this executable, which is basically this code here, that is on source, queue workers, and then whatever protocol you have, and then the name of the file is going to be the same. And the endpoint is going to be KDE main. And I think each one of them is going to initialize a class like this, probably. And these arguments here are the arguments that are being passed through the create worker. So it's basically the same because it passes through the file there. So through this file here passes the arguments through the other one as well. So it passes these arguments here through the process that initializes through here, and then it passes these arguments through the function here, which is ultimately going to run the KDE main for each, depending on which protocol you're running. So hopefully that's clear. So this is one of the most confusing parts. Oh, yes. So on the constructor also, so before it does this, on the same function there, on create worker, it's going to run the constructor for the worker. And this is the other part, the other class that is, I think, one of the most important for the optimizations is the connect class. So basically this flow here, I mean, maybe it's later actually. I think it's later is on the setup, but yeah. So m connection is the m connection is a member variable and it's going to be of the type connection, and is the class that actually I think that it is the class that communicates with the worker, basically. But this is the flow that's at the end there on the constructor of the worker. The worker class. So I think that's pretty much it on this part. Now here I wrote down on source queue worker files, blah blah. I just wrote down some stuff to look into later. Function queue worker calls on its return. It depends on which worker. I already talked about this. So as from that point, you can look into the code, and I think that the rest is kind of easy to see what it does. But basically, after it runs this, it's gonna run this setup worker, and then on this function is the one. So these three functions here, they are so this is one of the main functions of the optimization related to optimizations, because on this connection here is the function that is going to send information to the worker, and it uses QString, which is a class from Qt, in order to put the information, to write the information in bytes. I think that's the process is going to need. So this is one of the things that I didn't understand in the beginning as well. I think it's on the, I have to look into that. Just gonna search. So basically this function here. So it's gonna call these three functions, and the information that it passes here is basically the information of the URL, which contains, it's kind of like creating a header for an HTTP request, for example. So this is basically the information that you're gonna have on the config data and so on the protocol. And it's gonna call these functions on the worker, and then it's gonna use this QData string, which is basically, I think, a string of data, as the name says. So it's basically writing to the string on the information for the protocol. And then it's going to call this send function from this m connection, which is the connection class, which is going to follow this path here. Here, this function is a socket which writes a header to a buffer using the data argument passed to the function. Data passed to this function is the metadata for the protocol along with URL info. So I think this is one of the main functions. And I didn't spend too much time to look into how, or to understand exactly how it works, but it's basically this and the other functions that are the ones that matter the most. And I think what this is gonna be doing is gonna be used to communicate. So like, as far as I understand right now, is like setting up the information for the protocol on the class. So basically setting up the state. Then after it does this, it's gonna call the start job. So this is the last function that runs on the start a job function here. And this one is gonna initialize the worker before. So it's probably gonna communicate. So at the end here is gonna call this worker send function, which is exactly the same function that calls before. So it's basically eventually gonna call this thing here. I think it's basically the same thing. So yeah. So this is, I think, the final function that matters as well. So this function here is going to set up all the signals for the worker, like to keep track. If something happens, it probably sends a signal, which activates a callback function, and then it does whatever it has to do to, depending on what is the situation. So it sets all necessary info on worker state before when it executes the job commands. It already has all info needed, and the command is the only thing that matters to determine what the worker will do. Yeah. So both use the same function on the worker. Main difference is the data sent on each time. So I'm gonna go back to see. So it's gonna be on the worker. Actually, the function before I think is the one that matters. And this job I think is gonna be the same job from the beginning there. It is gonna be the same job because this job here is the starting job. So the job that runs the constructor there on the beginning is essentially this job here. And this is the function that is going to connect that job in the beginning with the worker. So start a private job. So it's basically this function here. And this worker is the one that runs the start a job function. So I think what it's doing, I haven't looked into the each function yet, and probably once look into, but obviously I think it's just connecting everything to setting up the state of the worker, and then it calls the send command. And I think that the sends is gonna the connection class is gonna communicate with the worker executable, and the worker executable is the thing that actually does the work. So basically, on the bigger picture, is just opening another process. That process is one of the folders there that is related to the workers, which depends on the protocol. That starts executing, and it opens this channel of communication between this the process of this code here, which is this worker basically, with the other process, the executable, and then sends information. So the one that actually does the work is the executable, I think, which starts on the KDE main. And I think that I couldn't see like the optimizations on this code because I think that most of the optimizations are probably gonna be done through the Qt classes. So I didn't spend too much time. I didn't spend any. I actually spent a little bit of time on the code for the worker there, the worker executable, but I didn't spend too much time. So I think that's probably what's gonna happen is that most of the optimizations are gonna be actually on the Qt source code, not on the KIO. So I think that this is basically the main function. I don't remember if I once. I think I didn't. But this probably just checks to see if it was initialized. I think I didn't once over this. Connection backend. Yeah, so I did. So this is the last function. So this is the same one that runs there before. So when it runs this function through the first time here, through the first flow, it's just putting the information, kind of like the header for the protocols in the beginning. And I think that on the end here is where it's actually gonna. So I think like the code that executes on the worker is gonna depend on the command you pass here. So like all the code's already on the worker, and then the main thing that's gonna change is what command you passed. And these arguments, which is the the bytes array of data here. From what I've seen there, it doesn't seem that like it has a lot of like it doesn't seem that matters that much. So I think the main thing that matters is the what command you pass, and then the worker already has like all the logic. So because the command is list there, I think from the beginning there, then the worker is going to know what to do based on that. So I think that the information that is writing on the socket here is not the information of the directory. It's just the information to execute the worker, probably. But these parts, like I stopped here, so I might this one I'm not 100% sure, like what happens, how the connection is done, because I didn't look into the code for the worker yet, and yeah, this is the last function that I seen on the flow there, and I didn't continue after this because all this stuff here, the flow that I wrote there, is after one function that is on the middle of this directory, which is essentially the function that I'm trying to understand, which is the open directory, the open URL. So what happens after you click open URL? So this is basically the function, and I stopped on this part here. So all that flow there of everything that happens is after it calls this function here on this one, and I didn't look into the other the rest of this stuff here. But I imagine, like I said, it's gonna use that connection and the connection backend to communicate with the worker process. And that code of the sockets is not the actual thing that's reading the directory. It's just the process of communication between the main process, which is this one, and the other process, which is the worker process that gets initialized on create worker. So probably in order to understand the optimizations, if you want to understand how KIO optimizes loading directories progressively, you have to look into the specific protocols and the functions here on the protocols to try to understand how it works. But I think that I'm not gonna do this for the other stuff that I'm doing there because I think which is probably what I'm gonna do now after. So I'm gonna stop streaming now, and I'm probably gonna come back and then I'm gonna try a different approach on the Explorer there because I think this one doesn't make a lot of sense. And also use ChatGPT to ask there, and it seems that it's probably going to be better to try to use Godot's threads and the stuff that Godot already has instead of creating the processes and stuff like that. So I'm going to try to progressively go from the editor file system that Godot has into a more optimized version that allows me to load the large directories without breaking the GUI. So I'm gonna stop here. So probably gonna be right back, a couple of minutes.